Good day, guys. I hope all is well. All right, welcome back to my YouTube channel again. Sttn124. Let me share my screen. Today I'll be doing Sttn124 test one preparations. And so I've received a lot of messages where students asked me to do videos for Sttn, really for the first chapters. So let me just do this. Put this one here. Okay, and you guys said the first chapter um is based on, the first test is on chapter study need 1.1 till 1.4. Interesting chapter. Just do this. All right, now let's look at 1.1. So 1.1, I can say 1.1 is based on the chapters that you guys did when you were doing STTN 311 module last semester. It was about the linear regression. And with the linear regression, you know that you guys did scatter plot. So now you measure the relationship between X and Y. So you know that if you are required to draw a scatter plot, you will have to use the X and the Y, which something I'm going to explain. But most of those things, the things that you guys did in the Sttn 311 module. And then after, you need to interpret. You remember, like we said now, if R it's equal to, for e.g., positive 0.95 for e.g., something like that, then we'll say that when you interpret the correlation coefficient, which is small letter r, then you're going to say that there is a relationship, there is a strong positive linear relationship between that x and y, because you're going to measure the relationship between x and y. Then after, it's when now you need to calculate or interpret the coefficient of determination. So those that you guys did in the Sttn 311 module. You also know about the residuals from Sttn 311. Now, with Sttn 124 module, then you guys will be given what we call stat 1.2 output. You'll be given this stat 1.2 output, then another stat 1.2 output, which is multiple regression. Then you have to make predictions. You have to analyze that stat 1.2 output. You answer the questions based on that stat 1.2 output. But you can't answer the questions based on that stat 1.2 when you don't understand the basics, so which is something that I'm going to explain now. But for 1.1, this slide, it's things that you guys did in Sttn 311, which I'm gonna be very fast when it comes to explaining them. But when it comes to the stat 1.2 output, then I'm going to be very slow because it's those kind of things that you guys will be given. Even this one, they will also test you like based on this. So if you look at this now, just gonna use this one. If you look at this one here, you are given the X as the hour studied. You're also given the Y as the test mark. So if you're given this and then they say you must now maybe draw the scatter plot. So you know that you're going to use the X and also the Y to draw a scatter plot. Use that them that I'm going to explain. Then now to measure the relationship, you need to find the R. You know how, I believe you guys know how to find the R in the calculator from Sttn 311 module to find the small letter r. Then after you interpret, once you find the small letter r, it's going to be interesting, like, or easy for you to find the coefficient of determination once you find the value of r. Okay, let's see. Let's see. Okay, we are given two variables. We're given variable x, we're given variable y. Remember what I said? When it comes to the linear regression, you measure the relationship between x and y. And the x, in this case, it's your hour studied. The test mark is the y. So the x, like for example, if you are required to draw a scatter plot because your graph is going to be something like this, and now this one will be your y, and this one will be your x. So this x here will be your independent variable. This x, that will be your independent variable, and then the y, which now will depend on the x. That will be the dependent variable, the y, like this. So that's how you see the variables. This one. Focus. Okay, then the scatter plot. Okay, this is how you draw the scatter plot. This is the way you're going to put your x, and then this is where you're going to put your y with regards to the scatter plot. Then you measure then your you use your points there, and then you draw a scatter plot. That's why I said that with 1.1, this slides basically is the things that you guys did in the Sttn 111 module. So this is just an example. We are given the x and the y, and then you are supposed to draw the scatter plot. Then this one also, it's when you check, or okay, how do you see that the relationship is strong? When you look at the scatter plot, you look at the line, it shows that it's increasing. That's why you see that it's strong positive linear relationship. Then when it's decreasing, look at the dots, the trend of using the dots. It shows that it's strong negative linear relationship between x and y. Then when it's weaker positive, when you look at the dots, they're still increasing, but now the dots, they are not close to each other. It's see, so that's why it's weak. And then even this side, the dots are not close to each other, and also it's decreasing. So that's why it's weak negative relationship between x and y. So yeah, then here there's no relationship. So it's or they say it's non-linear. Then this one is correlation coefficient, the one that you guys did is in triple one. If you want a recap of what I'm talking about, under my YouTube channel, you will see there's this video. It's Sttn 111 and Sttn 122 chapter 6. Yeah, that video. But it's written chapter 6. If it's not Sttn, if there's no Sttn 122 there, just check Sttn 111 chapter 6. That's the linear regression that I'm talking about. I'm talking about this slide. That's why I want to explain 1.2, 1.3, 1.4. This one is basically on my YouTube videos, or those who did one, because I believe those students who are doing 124, they did Sttn 111 last semester. And I believe you guys didn't have problem when it comes to this chapter. But if you have problem with the also this chapter, go in under my YouTube channel, go and check the chapter that I'm talking about, chapter 6, the linear regression. The linear regression. So this one, when R is greater than when it's started, that's when R is positive. We say that there's a positive linear relationship between x and y. If R is less than 0, then there's like negative linear relationship between x and y. Then when R is equal to 1, you get exactly 1. That's perfect positive between that x and y. If it's negative, then it's perfect negative linear relationship between x and y. But if you get the RS equal to 0, then we know that there is no correlation between the x and y. So that's how you get the whole thing. Then okay, then let's say that's how you look at the relationship, and then the visuality, the linear regression. Then this is the so when you guys were doing the linear regression last semester, you were using the formula which is y is equal to a plus bx, and you're using a calculator to get the value of a. You're also using a calculator to get the value of b. You say that. Then after then you write down the formula. Then that's your linear regression equation. You're using this formula. This one. So which I believe that you guys know how to find the value of A on a calculator and also the value of B on a calculator. Then that's how you draw the least square line, which is not that. Even the residual part, also this one, you guys did this one. Remember, if you don't understand it, check under my YouTube channel, which is Sttn chapter 6. Just check there under chapter 6. I'll try to put the link under the comments when I upload this video. I'll try to put the link there so that if there are any students who don't understand this, then they can also look at the video that I'm talking about. Because the one for multiplication for the step 1.2 output, I don't have that one. It's this one that I'm currently doing. And then that was the residual, and then what's the other thing? And that's how you make the predictions. There's also an interpolation where now you have to get your linear regression equation. Then after you look at the equation and then they tell you that they give you the scenario. On that scenario, they will give you the value of x. So you go and use your equation, linear regression equation, where you see x and you put that formula there, like this one here. Then you get the answer. After getting the answer, you're going to check if that answer is in the interval of the given observed x values. And if it's not there, if it's inside those interval, then that's interpolation. But when you check if it's outside the interval of the observed x values, then we're talking about extrapolation because it's outside. Extrapolation, which is this one here. Then the coefficient of determination also, this one is also there. Because I want to talk about the things that I know that they are not there on my YouTube channel for 124 module. Then also this the residual plot, so on. And obviously the outliers. We also guys talking about the outliers. Mm. So it's just an exercise. Okay, suppose the student studies. So here on this exercise, you need to find the equation. You're going to punch this on a calculator, x and y. You find the equation. Once you find the equation, where you see x, you're going to put 25. You're going to put 25. Already you are given the equation is there. Here it is. Where you see x, then you're going to put 25. Because the hours is the value of x. You put 25. Here they said, what will it be if he studies 40 hours? So where you see x, you're going to put 40, get the answer. So that's an exercise. Even this one here, already we're given everything here. It's just you interpreting self questions. That's why I'm interested in the one where you're given this that 1.2 output, because I saw that the students, most of the students were struggling when it comes to that part. Then started from 1.2. Started from 1.2. Which was this one. Alright, now let's see. I wanna talk about this one. Interesting. I wanna talk about this one. The one where students in problem. So now let's see. So last semester you guys were doing Sttn 111 module and you were dealing with linear regression where you're given x and the y. You said that the x you are talking about independent variable, the y you are talking about dependent variable. Now here with the multiple regression, you will be dealing with one more independent variable, meaning you will be dealing with two x values, like two more independent variables. It can be more, which can be x1, it can be x2, it can be x3, it can be x4. That's why we call it multiple regression, where you will be dealing with what? More than one independent variable, and you have to use those independent variables so you can be able to estimate the dependent variable. That's why we have to use the method of multiple regression. You guys are used to the formula of y is equal to a plus bx. Then now with the multiple regression, because you will be dealing with more than one independent variable, we will be dealing with what we call the intercept, which is with this side we call it BO. We'll be dealing with the intercept BO. We'll also be dealing with B1, B2. You can also have B3, B4 up until BXXK. The reason why they say BKXK is because you can deal with more than one independent variable. Now it's easy because This whole thing of multiple regression equation, it's there on the state output. It's just you looking at the output, you take the answers there. It's there. That's why the mark allocation is 1 mark, 2 mark. Most of the time it's 1 mark because they're asking you something that they know that the answer is there on the 1.2 output. So on how to get the BO, how to get the B1, B2, and so on. Obviously, the B1 will goes with the X1, the B2 goes with the X2, the B2 goes with the X2, B3, X3, B4, X4. Then now it's gonna be a part where you have to interpret the value of BO, to interpret the value of B1, to interpret the value of B2. Now, when it comes to the part of interpreting the value of BO, remember what I said, the BO is when you're talking about the intercept. I'm going to show you how to get that value of BO. So now to interpret that value of BO, so when now we say that it represents the value of Y. So that value of Y, we're talking about the value of Y where all those independent variables like x1, x2, up until xk. Remember, you can deal with we can deal with more than one independent variable. It can be like 3 or 4 or 5, even 6 of them, the variables. So that's the value of BO. It represents the value of Y. And then as for B1, that one it represents the change in Y. You can say that per unit. But the most important thing with the B1, you need to look at, you need to look at the output to check that value of B1, is it positive or negative? If it's negative, then that's only going to mention that there will be a decrease in that value, or there will be an increase if it's positive, something like that. Yeah. Then I'm going to show you guys an example. Okay, here it is. You'll be given something like this. Here. This is what you call state 1.2, but it's not the one that you will see. Like I think there's an example where I'm going to show you this is how you see that this is all your state 1.2 output. Here it is. For you to get the equation, you will be given a state 1.2 output. Then on that state 1.2 output, you look at if they say they want you to find the multiplication equation, then look at the part of regression coefficients. And under this part of regression coefficients, you have a lot of things. You have B parameter estimates. This one. When I look at this one, the small letter B parameter estimate. Always when you are dealing with multiple regression equation, look at the small letter B parameter estimates. When look at the small letter B parameter estimates, the first number here, you see this number here, when you check here, that's doesn't have like the variable where it's x1 or x2. This is our intercept. That is our BO. That's how you get the BO for this one. Then this one of 0.162, it corresponds with what? With the x1 and then the intercept if you go here. That is our B1. Remember, B1 goes with the x1. And then 0.249, it goes with what? With the x2. That is our B2. So in the B2, it goes with x2. So when you get the multiple regression, you want to say that y hat is equal to, remember it start with BO, 5.257. This one is plus 0.162 because it falls under the x1 intercept. You're gonna say 0.162 x1 plus this one is with x2, 0.249 x2. So that's how you do it. And then that's how you get the multiple regression equation. That's how you do it. Then when it comes to this part of, I'm going to explain what does this thing mean, this one, because now we are still under multiple regression. So to interpret this here, the value of BO, you're just going to say, you mentioned that value, you say that the value of what, that 5.257, it represents the predicted sale, okay, for what, because it's going to depend on the scenario that you'll be given. It's going to be based on that one. Then you interpret your value. Then when it comes to the part of 0.162, remember what I said? There will be an increase. There will be an increase in which value? That's 0.162 because it is positive. If it was negative, then we'll see that there will be an increase in that value for you to interpret the value of P1. Then after, you can also use the method of the one that you used last semester, where you said for every 1 unit increase in 1 and 2, there will be an increase in what, like, or you can also use this one for every 1 unit increase in 1 and 2, then the ads expenditure, something like that. So when it comes to this part, you just look at the value, you look at the scenario, you look at the X1 or X1 represent this, then you interpret based on that thing. If it's negative, then you will mention on your comment that there will be the increase. Then if it is positive, then there will be an increase. So that's how you interpret. Same applies to this one, looking at the value. Then the coefficient of determination, in this case, you will be given, since you will be dealing with the stat 1.2 output, you will be given you'll be given the coefficient of determination. Then you will be required to calculate what we call the adjusted coefficient of determination. So you should be looking at the formula. So this one, you know it from Sttn 111 on how to look at the properties and how do you see that the R squared is equal, if it's equal to 1, what does it represent? Is equal to 0. And then now this one. So this that I'm saying that you will be given the coefficient of determination, which is 0.9277, and then now you will be required to calculate this one of adjusted. So ADJ's adjusted coefficient of determination. So no, this one it was 0.9277. So if it's close to 1, now the least square line fits the data well because it's close to 1. The 0.9 something. I want to talk about this one. Adjusted coefficient of determination. This formula is very important. This formula R squared A, it represents adjusted coefficient of determination. Adjusted coefficient of determination, which is 1 minus n minus 1 divided by n minus k minus 1. And then open bracket 1 minus R squared. What does n mean? N is the number of observation. The k is the number of the variables. I call them the number of the variables that you guys will be dealing with. On that one. On that one. And then now when we check here on this part, you will also be given the n. You will also be given the n. How do you get the k? The number of, now I call them the number of independent variables, or you can say the number of predictors. How do you get them? Let's go back to this. Okay, here we know that for the multiple regression equation, we use the B parameter estimates like this. We use this one and this one to get our multiple regression. So now, this is what you do. Now, for the value of k, you're going to check how many intercepts you have. You have x1, you have x2. So it means you only have 2 intercept or 2 independent variables. That will be the value of k. So the value of k will be equal to 2 in this case. And then you say 1 minus, what is the R squared? R squared is this one that we are given, 0.9277. That is your R squared. It's your R squared. Then to this. So that's how you get the multiple adjusted coefficient of determination. That's how you get that thing. So that's how you substitute. N is 22 and then minus 1 according to the formula. 22, the 2 comes from the number of independents or the number of variables where it was x1 and x2 is 2. If I had maybe 3 variables, x1, x2, x3, it means that k will be equal to 3. Then you substitute your coefficient of determination and then you get your answer of adjusted coefficient of determination. Then after, then you interpret. Now, when you interpret based on the answer. If you got, let's say, 0.9201, you multiply it by 100, and that's 92%. You tell them that, okay, that 92% of that variation, remember, you're going to be depending on the scenario, because here they were looking at the sales and so on. Now, that 92% of the variation in sales, it can be explained by the independent variables, which that independent variables is x1 and x2. Because you only have 2 variables. So that's why you interpret the adjusted coefficient of determination. So this is an exercise 1. You should be given a stat 1.2 output. Where is it? This stat 1.2 output. You see, they put a question mark here. They want you to calculate that stat 1.2 output. What do you need for you to calculate the stat 1.2 output? You need n, number 1. You need n. You need n, this one. You also need R squared. You also need R squared. for this one. And what is your R squared? 0.7348. And you also need what? You also need K. So for the value of K, remember how do you get the K? You look at the number of independent variables. So when you check under the intercept, it's x1, x2, x3. So the value of K will be equal to 3. You only need these three things. And then already you know the formula of how to calculate the adjusted coefficient of determination. Because the minute that they put a question mark here, they will ask you to calculate the adjusted coefficient of determination. You substitute n is 113, r squared 0.7348, and then k is 3. You substitute, you get the adjusted coefficient of determination. So as for the equation, because you'll also be asked about the equation, look at the small letter b, parameter estimates here. This is how you're going to get your equation here. The first number here doesn't correspond with anything, correspond with the thing of the intercept. That will be your BO. So when you estimate now the second one here, it corresponds with x1. That will be your B1. The second one, B2. The third one, B3. So now, for your equation, you're going to say that y hat is equal to BO, which is this one here. Let me just do this, which is 11.148. Like this one, 11.148 minus, because this one is negative, minus 0.008x1 minus 1.258x2 plus the last one, 9.873x3. That's your multiple regression equation. That's how you get it. Multiple regression equation. So which is going to be under 1.3.3. It was the, I think, of the continuation. Yeah, that's how you get it. The other one was 1.2. 1.2. So that's how you get the whole thing here. Whole thing so far. So now I believe now you will know how to find the multiple regression output. I mean regression. You will also know how to find the adjusted coefficient of determination. So let's go to 1.3 and see. So 1.3 now we're talking about what we call the contribution of each variable, the contribution to R squared. Now this thing of the contribution to R squared is formed by two things. It is formed by the coefficient of determination, which is R squared. It is also formed by R squared I, which is now, it means that that value of R squared, if we look at what we call the ith independent variable, either x1, x2, x3, ever omitted from the regression equation. That's why ever this part of R squared minus R squared minus R squared I. That is the part where you see the contribution to your variable, to your R squared. Now, how do you see the thing? Now, if you are given a question and then they say, just that it's not here, that the part that I'm talking about is not, because this multiple regression outputs, that 1.2 is not complete. I'll show you the one that I'm talking about. How do you see it? To get the contribution to R squared. You remember this part here, R squared minus R squared I. That's the contribution to R squared. So they can say which variable contribute the most to R squared, which variable contribute the least to R squared, something like that. Then I'm going to show you how to find that thing. So here it is. You will be given a full stat 1.2 output, then on that stat 1.2 output. Then now, for you, if you're asked which variable contribute the most to R squared, go to your stat 1.2 output, check this part of contribution to, or contribution of the variable to R squared, like this. Here we're given only two variables, x1 and x2. So now look at this. Remember the part that I mentioned, R squared minus R squared I. You know, sometimes what they do, they will put a question mark here on 0.3021. And they ask, which variable contribute the most to R squared? You can't say that it's, for e.g., x1 without finding that unknown number, which is under x2. You need to find that to check, you compare those two numbers. To find this, it says R squared minus R squared I. This is where you're going to find your R squared I. This is where you're going to find your R squared. It's just a matter of your substitution. You say that 0.9277 minus 0.6256. You get the answer. I think it's what they did here. You get 0.3021. Just in case if you're not given this number, then you're going to compare between 0.5744 and 0.3021. Which variable contribute the most? That will be 0.5744. You write it. 0.5744 contribute the most, which will be the x1, meaning x1 contributes the most to the R squared, to R squared. If they say contribute the least, that will be x2. So x2, you write that number 0.3021, contribute the least to r squared. So that's how you do the thing of the contribution. When it comes to the normal probability plot, it's with regard to the residuals. When those dots they are close to each other and with the trend like a straight line, they are close to each other. It's when we say that the residuals are normally distributed because the assumption of that normal probability plot, they are met. It's met. It's met. So then we see that the residuals are normally distributed. Comes to that part, and then yeah. Then if now the dots are like this, you see when you try to do the straight line. So this one you'll be just given the graph, and then they're going to ask you questions based on the graph. Maybe to check whether you're going to say that the normal distribution plots are distributed or they are not just normal distributed. But if you are like this, then they are not normal distributed. You see, are not normal distributed because the assumption is not met on this one. And then okay, it's just an exercise where they give you a thing. So I'm interested in this one. Look at this one. This is your multiplication output. So multiplication output on this one. Now you should check here, just that we're given the adjusted coefficient of determination. This is your contribution, the one that I'm talking about, contribution to r squared. You are given the value for x1 and x2. So they give you questions, they say, no, which variable contribute the most? You're going to take 0.2251, that will be x2. So x2 contribute the most to r squared. The other one, if they say which variable contribute the least, that will be 0.0075. That will be x1. So x1 contributes the most. And if you're not given this value here of 0.2251, then put a question mark. How do you get it? 0.6045? No, 0.8296 minus 0.6045. You get this one if they put an unknown here. So that's how you do it. So this one is easy. It's one of those chapters that are interesting. And then now for 1.4. 1.4, this is one of the question where most students are struggling, and it's easy. So I'm gonna show you guys a strategy on how to solve this whole thing. Let's see. It's what we call statistical significance regression coefficients. Now, the statistical regression significance regression coefficients, it's based on the hypothesis testing. The hypothesis testing, we say that we have what we call HO. So let me try to do this. So HO now, it represents what we call null hypothesis. Hypothesis. Hypothesis, HO. We also have what you call HA. So other students from the other universities, they use H1, where they call it alternative hypothesis. Alternative hypothesis. Hypothesis. Alternative hypothesis. So now, when you formulate, you will see that when you guys do this hypothesis testing for one population, hypothesis testing for two population, hypothesis testing for the matched pair difference, I mean experiment where you are dealing with the difference and so on. So HO, whenever you see HO, think about it's null hypothesis. HA, alternative hypothesis. Now, here because we are still under multiple regression, we will say that we remember still dealing with the parameters. We are still dealing with the B parameters. So the reason why they say that BI is equal to 0 is because those parameters we can have maybe B1, B2, B3, B4, depending on the number of variables that we are dealing with. So HO, we say that BI is equal to 0. HA, BI is not equal to 0. That's how you formulate your hypothesis, null hypothesis and alternative hypothesis. That's how you formulate it. If you're given a question and that question is specifically focusing on B2 for AG, parameter B2, then you will say that HO B2 is equal to 0, HA B2 is not equal to 0. That's how you do it. That's how you formulate the null and alternative hypothesis. Now it's time for you to make decision. When you make decision, we have what we call the p-value. The p-value, this p is a probability. You still remember when you guys were doing Sttn 111 last semester? you before you get the probability, you have to find what we call the standardized normal distribution or the standardized value, which is the Z. Some they say the Z, the Z, and so on. Yeah. We have to find that the Z or the standardized normal distribution or the standardized value. You use it, you go and check on the standardized normal distribution table, you get the probability. Here you'll not be required to find the probability on a table. You will be given the probability on one state 1.2 output. It's just you comparing. You'll be given the probability. You'll also be given what we call the level of significance, which is alpha. This one here, you'll be given the alpha. If you're not given the alpha, they used to say that you must use 5%, which is 0.05. So now here, if that p-value is less or equal to alpha, meaning the bigger number will be the alpha, you're going to reject your null hypothesis. You're going to reject the null hypothesis. But now, if the VP value or that probability is above the null hypothesis, is above the level of significance, which is alpha, you do not reject the null hypothesis. That's when you fail to reject. You're also going to stay there or you fail to reject. Now, here's the thing. Be careful of this. The minute you reject, because the question is going to ask you now, which variable is statistically significant? So for you you're not going to with this kind of question, don't cry because I think it's 3 marks, 3 marks, 4 marks, yeah, just 3 marks. You're going to compare. You're going to for x1, x2, x3, do all of them. The way you know that you're going to reject when you compare probability with the alpha. Those ones will be statistically significant. Why? Because you rejected the null hypothesis. But the ones where you failed to reject, they are not statistically significant. You will see. I'm going to show you by one question so that you can see. Okay, how do you get your probability? Let's go back to 1.3. You see this values here, prob greater than this t. This is how you're going to get your probability values. That p is your probability values. They're going to ask you which variable is statistically significant. Okay, you go here. You on your side, you know that you are dealing with what? With x1 and x2. You're not going to use the 0.914. You're dealing with the one for x1. You're dealing with the one for x2. You're going to start. You're going to say HO. We can either use this one. HO, where B1 is equal to 0. HA, B1 is not equal to 0. You're going to do that. Now, you're going to compare. Let's say alpha, you're given 5%, 0.05. You are going to say now, you're going to compare. You're going to say for AG, do this. You're going to say the P is 0.348, 0.348. So is 0.348 less than 0.05? No. 0.348, which is above 0.05. What do? We fail to reject. So we fail, fine. We fail to reject HO. What if the minute you fail to reject HO, then it is not statistically significant because you fail to reject like this. Then let's go to the other one. This one, you want to write, you want to look at the question. If they say they want the variables that are statistically significant, then you're not gonna take this one. But if they say they want the variables that are not statistically significant, you're going to take this one. Let's go to another one. Another one here we have 0.001, 0.001. Between 0.001 and 0.005, the bigger one is 0.05. So you're gonna start at 0.05. If it's like this, what we do? Reject HO. The minute you reject, it means it is statistically significant. And then you're gonna write there where x2 is the one which is statistically significant. But remember, don't forget to formulate the null and alternative hypothesis when you state your decision. So that's how you do it when you come to this part. So 1.4 is this one. So just to here, they was just showing the probabilities. That's how you find them. You see, all the p-values of the regression coefficients is less than alpha. The bigger one will be the alpha that you'll be given. Let's say 0.05. So all of them, they will be statistically significant. Why? Because you rejected the null hypothesis. So that's how you do it. That was 1.4. That was 1.1, 1.2, 1.3, 1.4. So with me, I have 2024 question paper, but I think it's the question paper as the memo. I think so. I'll just check. No, it's not the question paper with the memo, but I'm just gonna explain some few things since I explained the basics, which I think you guys now, it's going to be easy for you to do this. Okay, by referring to the scatter plot, what relationship exists between the number of, okay, kilojoules a student? So here you just look at the scatter plot. This is our scatter plot. Is it increasing or decreasing? Also, you check also the R, 0.9763. Shows that it's increasing. So there's a strong positive linear relationship between the X and the Y. And the X is what? The kilojoules consumed, and the Y is what? The concentration level. So yeah. And then does the Pearson correlation coefficient support your answer? Yes, because there is a strong positive linear relationship. It's 0.9765. And then interpret the value of the slope of the estimated. You look at your equation. 0.46. This question is basically the one on Sttn 111, but it's just that this one is not a multiple choice. 0.0051, that will be your slope. And then you interpret it's positive so that there will be an increase on that part. And then calculate and interpret the value of coefficient of determination. Now already you have your R. You remember when we're doing Sttn 111, the minute you get R, for you to get the R squared. This one you're not given the stat 1.2 output. You're not given the thing, the one that you for multiple regression. For you to get this one, you know that you have to square it. You have to say open bracket 0.9765 close bracket to the power 2. You square it, then you get your answer for coefficient of determination. That's how you do it. Then after then you interpret. If it's close to 1, the then the slope fits the data well. The line, the regression line fits the data well. Then Mona, then you look at your equation where you see X, you put 950, which is this equation here. This equation where you see X, then you put that 950, then you get the answer. You see, then they want to ask you whether this is the prediction is based on the interpolation or extrapolation. That answer, if it's inside the observed X interval, observed X value, then that's when you say that it's interpolation. But if it's outside the observed X value, then that's extrapolation. Then for this one, you remember for the residual, we say the Y, for the residual, the Y and minus the Y hat. The Y hat is your equation. So the value of Y already, you are given 5.0. Now the value of Y hat, for you to get it, you need to use the equation. On the equation, you will also have X. Then how do you get the X? You're going to use 950 so that you can get the Y hat. Then you say that 5.0 minus the Y hat. Then you get your residual. Then this is your stat 1.2 output, that the one for multiple linear regression. Okay, you are given x1, x2, x3. So how do you get this one? ADJR squared, adjusted coefficient of determination. You need three things for you to get the adjusted coefficient of determination. What do you need? You need n, number one. Number two, you need coefficient of determination, r squared. Number three, you need the value of k. How do you get the value of k? The number of the variables or the independent variable x1, x2, x3. The value of k will be equal to 3. You need those. Now, another thing, for you to get the multiple regression equation, you need the small letter b parameter estimates. So the first number here, that's when that is your BO. So your multiple regression linear equation, let's look at the equation because I believe, write down the equation of the estimated regression model. They are looking for that equation. How do you get it? Y hat is equal to 45.200 plus 0.750 x1 plus 1.800 x2 plus 0.30 x3. That will be your estimated regression model. And then you see, interpret the value of B1. What is the value of B1? 0.750. Which is the one for X1? X1 represent the train hours. Then you're going to tell them that the value of 0.75, the train hours, there will be an increase because that number is positive. But yeah, then that's how you're going to interpret that value. And then calculate and interpret the adjusted coefficient of determination. 3 marks, just free 3 marks, because I've showed you guys the formula that we're going to use on this one. That one of 1 minus n minus 1 divided by n minus k minus 1, and then open bracket 1 minus r squared. You substitute, because I told you that you only need 3 things. Number 1, n. Number 2, r squared. Number 3, the k. Which now the k will be equal to 3, because you are dealing with the 3 variables. And then what's another question? Which exponential variable has the largest impact? The largest impact, the contribution to r squared. They're talking about the contribution to r squared. When they say the largest, you go here, contribution to r squared. You check, you have 0.182, you have the a here, you have 0.1495. Before you can get the answer, you need to get this unknown. How do you get the unknown? Remember I said you're going to use r squared, 0.6820 minus 0.546. You get this a here. Once you get the a, you're going to compare them, which number is the largest. Then after, you're going to write them down. And that x1 is the one that contributes the most to the, when you get this question, they said what? To the largest impact on the job performance. Then after, then you're going to motivate to answer by looking at that estimated coefficient, which is this one. And then now, the last one, it's, which one? No, the 2.6 was the number that contribute the most. Yeah, this one. So the answer, that the one that I was explaining now, it was 2.6. The one that contribute the most, but you still need to get the value of A. So as for 2.4, the exponential variable that has the largest impact, it's when now you need to look at the estimated coefficients between the one for x1, x2, and x3. The number that is the bigger. You want to check it, and then after, then you estimate. Then another one, it's for each exponential variable, state whether the coefficient is statistically significant. Then you need to see the variable that they are statistically significant, the coefficients. They're talking about x1, x2, and x3. This one, 3 marks. Formulate HO where BI is equal to 0. BI is not equal to 0. Let's start. Let's get the probabilities. Then you can also use this method. HOB1 is equal to 0. HOB1 is not equal to 0. Let's get the probability for the first variable. Where is it? For the x1, which is this one, 0.001. You are given the alpha of 1%. You're given the alpha of 1%, which is 0.001. You're going to compare between 0.0001 and 0.01. Then the bigger one will be the 0.01. Therefore, what you do, you reject. Meaning already x1 is going to be statistically significant. Go to this one, same thing. Go to this one, same thing. So all those variables, they are statistically significant. Then you're going to write them down. That's why you're going to get 3 marks. Then for the conclusion, it's when you're going to say you reject. Then you tell them that they all the coefficients, or the regression coefficients, are statistically significant for that one. This one, now you got your value, you got your multiple regression equation. This one, the hours will be the x1, the 3 years experience will be x2, the 45 calls will be x3. Let's go and check. Because you're given your x1, train hours, x2, experience, x3, the calls. So where you see you're going to use your multiple regression equation. Where you see x1, you put the 10, x2, 3, x3, 45. You get the answer that is for 1 mark. So the whole thing is out of 24. So it's easy to get distinction. So you guys will also do 2025 paper and then check. So yeah, thank you guys, and please don't forget to subscribe, and please share and subscribe to my YouTube channel, so that you can be able to see more content for Sttn 1 to 4. And good luck with your test. Danko.